Today we focus on probability. We're going to look at how to interpret questions under probability. This is a question involving independent events, which says the independent probabilities that Abba and Ben can solve a certain mathematical problem are half and 1/3 respectively. Given that both of them attempt the problem, find the probability that A, both of them will solve it, B, none of them will solve, C, only one of them will solve, D, at least one of them will solve, E, either Abba or Ben will solve, F, neither Abba nor Ben will solve. Given that only one of them solves, find the probability that it is Ben who solved. So as you can see, the keywords in the question have been underlined. So you note how I'm going to interpret each of them in the solving. The first thing is that the events are independent. That is the key word in the question. Once two events are independent, the probability that both of them can occur is simply the product of their individual probabilities. So it's good to know. So we say let Abben or Abba be A and Ben be B for simplicity. Then P of A, that means P of Abba solving, would be half as the question stipulates, and P of B would be 1/3. And then if I go now to the solving, the A part, both of them solving, it should be the case where we are looking for P of A intersection B. Both, that means A and B should succeed. So Abba succeed to solve and Ben also succeed. So this probability is simply the product of the individual probabilities. It's half into 1/3, which is 1/6. In the B part, none of them will solve. It's the case where Abba fails to solve and Ben also fails to solve. And this is simply P of A prime times P of B prime. Now A prime is simply 1 minus A. So the P of A prime is 1 minus P of A. P of A being half, I should be talking of 1 minus half times 1 minus 1/3. This gives half into 2/3, which is 1/3. The C part, only one of them solves. For you to have only one of them solving, you have two options. It is either Abben will succeed and Ben will not, or, so we add the options because of the or. The case where Abben will not succeed and then Ben will succeed. So this gives us P of A is half into P of B prime. B prime is 1 minus B, and B being 2/3, B prime should be 1/3, plus P of A prime. A prime is 1 minus half, which is half, into B, which is 1/3. So we end up with 2/6 plus 1/6, which gives 3/6 and a half. The D part, it says at least one of them. P of at least one should be the case where either Abba will solve and Ben will not, or Ben solves and Abba does not, or both of them solves. So this should be P of A prime intersection B plus P of A intersection B prime plus P of A intersection B. So here Ben can solve and Abba does not solve, or Abba will solve and Ben will not solve. So there is at least one person solving. At least. So includes the fact that both of them could solve. And this has a shortcut which is simply 1 minus none of them solving. Okay, you verify. You first get A prime times B plus A times B prime plus A times B, and you add them, it gives the same, because the fact that only one of them can solve or both of them can solve, and the fact that none of them will solve are complementary events. That means they sum up to 1, and so the shortcut would just be getting 1 minus none of them solving, which should be 1 minus, we had none of them already solving, which was 1/3, and the answer should be 2/3. Then for E, either Abba or Ben. So we are talking of P of A or B, and this should be P of A plus P of B minus P of A and B. The compound formula, the compound event formula actually. So this gives P of A, which is half, plus P of B, which is 1/3, minus P of A and B, and P of A and B, we had it as 1/6, the product of the two. The LCM is 6, give 3 plus 2 minus 1, which is 4/6, which gives 2/3. And then for F, neither Abba nor Ben. P of A, P of neither A nor B is simply the complement event of either of them doing it. So it is supposed to be 1 minus P of A union B, because this actually means P of A prime, P of A union B all prime, which leads to this. And so this should be 1 minus 2/3, which gives 1/3, because P of A union B, we had it in E as 2/3. This event, you note that the event P of A union B all prime is identical to P of A prime intersection B prime, and so it is like the case of B that we had already, because B was actually P of A prime intersection B prime. This relationship is De Morgan's law, and you can confirm that P of A union B all prime that we have had in F being 1/3, it is the same as P of A prime intersection B prime. It still gives you 1/3. So we could have used that directly to have the same answer as we had in the previous work. It was 1/3. And then finally we have G. Given that only one of them solves, find the probability that it was Ben who solves. So it's like saying P of B given only one. That is the same as P of B intersection only one all over P of only one. And actually P of B intersection only one should be P of B only. Only B solving all over P of only one. The reason is that if I have the sets, let's look at it this way. There is A prime intersection B and A intersection B prime, because actually the set only one of them includes these two. For it to be that there is only one of them solving and it is B who solves, boils down to only B solving. So that is why we can now say that P of B given only one is simply P of A prime intersection B all over P of only one, which is the sum of these two, and we had it already. P of only one is the C, and the answer of C is half. So I'll be talking of A prime intersection B, which is A prime is half into B, which is 1/3 all over the probability that only one of them solves, which we had as half. So at the end the answer is 1/3.